These are the topics that we are going to treat: introduction to programming concepts, representation of the programming logic using pseudocode, understanding iteration and modular programming, working with large volumes of data. Okay, so let's start with introduction to programming concepts. Now, we're looking at what does a computer do? A computer is a machine that accepts an input, processes it, and gives an output. Then, how does the computer accomplish this task? Before the computer can be able to accomplish these three tasks, it needs to be programmed. The computer needs to be programmed. And so what is a program? A program is a set of instructions to perform a particular job. So you need to give the computer some set of instructions for it to execute whatever job that you want it to do. A computer is designed to accept an input, process it, and give an output. So we call it the IPO, that's the input process output cycle. Now, let's relate the operation of a computer to our everyday life operations. Take for instance the first one, crossing the traffic signal while driving. It's a process. You need to get a signal, then from that signal you take an action, whether to stop or to move. And it's also similar to the way a computer works. Managing your budget is also another example. Troubleshooting why your printer is not responding is also another example. All these three processes are similar to the way a computer works. Now, before a computer can work, computers don't understand any language. They cannot speak English, they cannot speak Spanish. All they understand is a set of zeros and ones called machine language. They only understand zeros and ones. And that series of zeros and ones is what we call machine language. For instance, if you want to tell the computer to add the set of zeros and ones that the computer needs to read are 10100000100. Similarly, if you want to tell the computer to subtract, you need to code for the computer to read the machine language 101000100. So, as I was saying, the computer cannot speak English. It doesn't understand English. It doesn't understand Spanish. All it understands is a set of zeros and ones. So how do we then instruct the computer? There are a set of languages that we use to communicate with the computer, because human beings also cannot understand zeros and ones, which is the machine language. So there is an intermediary language that the two, either the computer and the human, can both interpret. That's the midway language called the programming language. So some of these programming languages are C, C++, and Java. So that is why we are going to go through this video to show you how to build the logic behind coding for these programs. Now, for any programming language, we have keywords, just like for any non-English language or any Spanish language, we have certain vocabulary. Now, for a programming language, we also have keywords. The keywords are the vocabulary of that programming language. Now, after the keywords, you also have the construction of the sentences, how to construct the sentences so that you can form meaningful sentences, and that is the grammar. The grammar for a computer language is called syntax. So the syntax has to do with how to place the various keywords for the computer to be able to understand what you want it to do. A compiler is a special program that processes the statement written in a particular programming language and converts them into the machine language for the computer to interpret. So what the compiler does is the work of like a translator. The compiler will, after you have written your program, the compiler will change all those keywords and commands that you've written into a set of zeros and ones, which are the machine language. Remember, I told you the computer does not understand any other language apart from zeros and ones. So after you have written your program, and let me come in here, every program is written in English language. Now, the computer cannot understand English language, so it needs the compiler to convert that English language into a set of zeros and ones, which is the machine language. Before we proceed to look at certain examples of programs, let's look at algorithm. Now, what is an algorithm? What is an algorithm? An algorithm is a sequence of steps required to solve a problem. So basically, an algorithm is the sequence that you use to solve a problem. For instance, when you approach a traffic signal while driving a vehicle, the algorithm to take the decision will be. So when you approach the traffic light, what are the sequence of steps that you need to follow before you can move out of that area? The first thing is, for any algorithm, you need to start. So first thing, you start the algorithm. Then the second thing is you approach the traffic light, isn't it? You approach the traffic light. Now, the next thing is you look out what color the traffic light is showing. If the light is red, then you stop. If the light is yellow, you slow down, then you stop. Otherwise, the light will obviously be green, then you can continue driving. And every algorithm must end. Every algorithm must end, then you end the algorithm. Let's look at another example of an algorithm. Consider an algorithm that a computer can use to accept a number from a user. Okay, so you want the computer to accept a number from you, the user. So you start the algorithm. Then the second step, the computer needs to accept a number from the user. Third step, if the number is greater than 0, then you display the number is positive. Otherwise, you display the number is negative. So this algorithm is looking at an algorithm for a computer to accept a number from a user and determine whether the number is positive or negative. Now, algorithm is not always written in the form of bullet points, as we saw. We can also have an algorithm which is in a form of a diagram. So when you write an algorithm in a form of a diagram, then we are looking at a flowchart. So a flowchart is a graphical representation of the steps to be followed for solving a problem. So similar to algorithm, but this time round, you have the steps in the form of a chart. We have standard symbols for drawing out a flowchart. You can see an input is looking like that symbol that we have. This one is a symbol for input. Then this rectangle is a symbol for a process. Then this symbol is for an output. Then this one is for decision making, whether it should be yes or no, or true or false. Then this one is used to define a procedure. We will look at procedures in other videos. Then these are the flow lines, initiator symbol. Then we have on page connector, off page connector annotation. We'll go into details on how to use these symbols. Now, look at a typical example of a flow chart. And this is a flow chart for the algorithm that we just saw at a traffic light. You start the algorithm. So as you can see, you see that to start the algorithm, you have the symbol for the input. Then approach the traffic light, you have the process symbol. It's a process symbol. Then you come to the decision side, what you have to do. So is traffic light red? If it's red, then you take this path. Yes. If it's not red, then you go through this line. Now, assuming you take this path, yes, then it will take you to stop. Then you end the algorithm. On the other hand, if you go through the no flow line, it will take you to another decision point. Is traffic light yellow? That's another decision point. If yes, then it will take you to slow down. If no, it sends you to light is green, continue driving, then you end the algorithm. So you can see that this chart represents exactly the algorithm that we saw. Now, apart from algorithm and flowcharts, we also have another way of representing logic, computer logic, and that way is called pseudocode. Now, the meaning of pseudocode is false code, meaning it's not an actual computer program code, but it is very close to a computer program code. The reason it's not an actual computer program code is that you are not going to use the keywords in the programming language. For a pseudocode, you use normal English language words. So a pseudocode is very similar to a computer program, but it's not a computer program because it doesn't use any computer programming language keywords. Now, let's look at how you write the pseudocode for the algorithm at the traffic light. For the pseudocode, in place of start, we have begin. Begin. Now, after you begin, you need to declare your variables. And in this case, what are the variables here? The variables that we are going to look at are the color of the light. It's a variable to it. A variable is any thing, any character that will change. And the action is also a variable because your actions will change based on the color of the light. So these are the two variables. The reason we are putting character here, the character is defining what kind of variables. So we are trying to say that the two variables, the light and the action, are character variables. They are not integers, they are not numbers, they are characters. So that's we declared our variables. Now, after declaring variables, you need to accept light. Accept light means the computer will allow you to enter the color of the light, whether red, yellow, or green. So computer needs to accept an input from the user, which is the color of the light. Now, when it accepts the input, then it will evaluate the input. If the input is that the color of the light is red, then the computer will begin a new course of action, which is action that it will do is to stop. Then it will end the program. Else, if the color of the light that the user entered is yellow, then the computer must begin a new action, and that action will be slow down and then stop. Then it will end the program. Else, if the color of the light entered is neither red or yellow, then the computer will begin a new set of action, which is meaning that the action will be that continue to drive. So you see clearly from this pseudocode, the color of the light tells the computer what you should do, and the color of the light is an input that the user of the computer that will be required to enter into the computer program. So my colleague will take you through the second video, which deals with representing the programming logic using the pseudocode. So let me wrap up what I said. In this video, what I showed you basically was that I introduced you to what a computer is. A computer is any machine that accepts an input, processes it, and gives an output. So that cycle of activities is called input, process, output cycle. Now, before a computer can perform its tasks, it needs a set of instructions. The computer cannot do anything by itself. It needs to be instructed to do whatever it has to do. And those set of instructions is called a program. Now, a computer cannot understand set of instructions written in human language. If I say human language, I mean English, Spanish, German. The computer cannot understand it. All the computer can understand is a set of zeros and ones. For instance, if you want to tell the computer add, you have to write this long set of zeros and ones. Human beings, on the other hand, cannot also memorize these set of zeros and ones. It becomes tedious. So there is a midway language that humans can learn, and the computer can also compile, and both the human and the computer will get understanding of each other. And those midway languages are what we are calling computer programs. Give examples as C, C++, and Java. The compiler is something like a translator, which converts the programming language, which is written in English, German, or Spanish, into the set of zeros and ones called machine language that the computer can understand. But the computer cannot understand the programming language that the human has written. Now, we looked at algorithm, which is a sequence of steps to solve a problem. And we continued with how to display an algorithm in a diagram called flowchart. These are some of the symbols. Then I showed you the slightly closely related code, which is not a computer program, but it is very close to a computer program called pseudocode. And I gave you an example of how it is used for the traffic light algorithm. So I'll hand you over to my colleague to take you through the next couple of slides. Hope you enjoyed this lecture. Thank you.
Hello there, my name is Francis, and in this video we are going to talk about representing the program logic using pseudocode. The subtopics we are going to deal with are variables and constants, data types, using operators, and lastly, conditional execution. Firstly, let us look at variables and constants. So what is a variable? Let us assume a user enters a value, okay? That value is stored in a specific location within the memory of a computer. Okay, so that memory location, the friendly name we give to that memory location is what we call a variable. So generally, variable is a memory location that holds a value. Okay. A constant, on the other hand, it's also a memory location that holds a value. But the difference between a constant and a variable is that with a variable, you could change the value. But with a constant, you cannot change the value throughout the program execution. In this slide, you can see a representation of variables and a memory location. So below, it's your various variable names. On top of it, we have the memory allocation in the boxes for 10, 15, and 25. And on top of it, we have the address of the memory location. So this generally represents the variables that you have stored in memory. The data types. There are broadly two main data types. That is the numeric data types and the character data types. With the numeric data types, you can only take numbers. Any number you could think about the age of a person, the price of a commodity. And with the character data types, you can take a number, you can take a letter or a special character. Now, let's look at declaring variables. Before you write a program, you need to allocate a required amount of memory that you would need for that program. And the syntax through which or in which we could represent this memory or we could represent this variable that are stored in this memory is what we see on your screen. Firstly, you could have your data types and then followed by the variable name you want to give to your variable. So the data types is simply the type of data you are storing, and the variable name represents the name you want to give to the value you are storing. Rules for naming variables. Before you name a variable, they must abide by these three rules you see on the screen. Firstly, your variables must consist of letters. It can be uppercase letters or lowercase letters. It could be digits or underscore. Secondly, it must begin with a letter or an underscore. And lastly, it must not contain the special characters you see on the screen. Question mark, exclamation mark, dollar sign, percentage, and all the various special symbols you see on the screen. Variable naming conventions. On your screen, we have three variable naming conventions. The first one, what you could do is that the first letter of your name will represent the data types, the data type, followed by the name that you want to give to your variable. So you could see C, name, and age. The second naming convention, the variable should clearly describe its purpose, like end score. End score tells you that it is a score of a game or anything. And lastly, the variables can consist of multiple words where the first letter of each word will be capitalized as what you see on the screen and total score. So the first letter will be capitalized. So total, the first letter is capitalized, score, the first letter is capitalized, sum of squares, so sum capitalized, of capitalized, square capitalized. Assigning values to variables. Now, all variables, okay, all variables, you first have to assign value to them before you use them, okay? And these are the two ways in which you can assign variables. You can do a direct assignment or accept statement. So with direct assignment, okay, what you do is that you'd equate your variable name, okay, with a value you want to assign. So your variable name will be on your left and the value you want to assign to it on the right. So in there we could see n height equal to 72. So your variable name assigned to 72. C code, variable name C code assigned to the character X, Y, Z. And the accept statement. All the accept statement does is that the computer will accept input from the user. So the accept statement will receive a value from the user, and that value will be assigned a variable, and that is what we call accept statement. Using operators. Now, all computer programs provide tools for operations, okay, and some of the tools we have are the arithmetic operators, the relational operators, and the logical operators. Now the arithmetic operators are used to perform your arithmetic calculations such as your multiplication, addition, subtraction, and division. And relational database are used to compare two or more things, or it helps you make decision. That's what you see over there, the double equal to sign, the less than or greater than sign. Those are your relational operators. And we have your logical operators. That is when the and or not comes in. They help you in decision making. Now let us look at the arithmetic operators. Now arithmetic operators help us perform some calculations. So assume you want to add two numbers, the arithmetic operators will help you perform that. And the table you see over there are order of precedence. So let's assume you have 2 times 3 plus 4. The precedence table will help you know that the computer will first multiply first before it will follow on to the next higher order operator. So the multiplication has a higher precedence than the division, followed by the modulo sign, followed by your addition and subtraction. So whenever you are performing arithmetic operation, this is the order of precedence you follow. So like we have over here, we have operator multiplication, and we have the results it will give you. So we have various operators, an example, and the value after the operation. So this is an example you could try on your own if you know any programming language. But for now, we are not dealing with programming language. But in general, these are some of the arithmetic operations you see. Okay, now let's look at relational operators. Now, relational operators help us compare two or more things. Okay, so if we want to compare Kofi with Amma, or we want to compare Francis with Alfred, the relational operators will help us do that. Now, the table in our next slide will give us commonly used relational operators. Now, these are the commonly used relational operators over here. Okay, so we have our equal to operator, will help us compare whether two or more things are equal. The greater than to check if one letter is greater than the other. The less than, which is to check if one number is less than the other. The not equal to sign to check if this is not equal to the other. The greater than or equal to sign, which also to check if this number is greater than or equal to the other. Now, logical operators. Now, logical operators, okay, they help us make logical decisions. Okay, so let's assume you want to make a decision. Okay, you want to combine two things, so Kofi and Amma. So logical operator will help you write an N, or you want to say Francis or Alfred. So the logical operators will help you here. So this table represents the precedence of the logical operator. So the not has a higher precedence than the N, and the N has a higher precedence than the or. So this is some of the examples of the logical operators. Okay, so the n, we could say n num1 is double equal to 7, and n num2 is greater than or equal to 5. So use the logical operators to get the results over here, and the n logical operator is what you see here in an example, and the or is what you see over here also in an example, and the not is what you see over here also in an example. So let us go on to look at conditional execution. Okay, so most problem in real life, okay, you don't handle them with simple computational numbers. Okay, you mostly use decision making, okay, to solve such problems. So the if there are two main decision making constructs that we'll talk about here. We have the if construct and the switch case construct. Okay, the if decision making construct. Okay, the if construct. Okay, is what you see on your screen. Okay, and we have a pseudocode representation of the if construct. So if this, then do that. You see, so if this is true, then do that. So on your screen, you see if and a condition, then you begin your program execution. So this, what you see on your screen is just a pseudocode representation of the if construct. So the next construct we have is the if else if. So let's assume if the first condition is true, okay, you have to execute a code in between the begin and the end. Else, if the condition is false, then you have to execute the condition in between the else construct. Okay, so the if handles the first condition, and if that condition fails, the else handles the second condition. Okay, and we have a pseudocode representation of the if construct. So if the numeric number 1, okay, if that number, right, modulo 2 is equal to 0, okay, what I want you to do is display that the number is even. So if this statement you see over there, if this condition is true, then what will be displayed on your screen is that the number is even. But if it is false, what will be displayed on your screen is that the number is odd. Okay, so in here we are looking at an example of a conditional if else construct, which is nested. So you start with the first condition. Okay, if that first condition is true, okay, you would execute your statement. But if it is false, we are going to check again another condition in that false statement. Okay, so if the condition you stated is false, it will come to the else construct. Okay, so inside the else construct, we are going to check again if that condition, that the if failed to execute. Okay, so we are going to check that condition again. So if we check that condition here and it is true, then this statement you see over here will be executed. But if it is false, the statement you see on the else will be executed. So this is the syntax for the if else construct in a nested form. And we have a pseudocode representation over here. So in here we have 3 numbers. So with the first condition, if then n num1 is equal to n num2, okay, you are going to display it as equal. But if it is false, what you want to do is that we have to check again if the n num1 is greater than n num2. Okay, so if that holds true, that is when you can display n num1. But if it is also false, that is when you want to display n num2. Now let us talk about a switch case construct, and this is the syntax for the switch case construct. Okay, so you begin, then you declare variables. You can declare a variable somewhere. So you start with a switch statement. So you start with your switch and your condition, so the expression, then followed by your various cases. So if case 1 is true, the statement you see here will be executed. If case 2 is true, the statement here will be executed and the code would end. So this is the syntax for the switch case construct, and we have an example of the switch case construct. So inside the switch case, we have our condition. Okay, so the condition is n num. The condition, okay, or the variable is n num. Okay, so the cases you see over here are the various conditions. Okay, so if case 1 is true, That means if num1 is equal to 1, then you are to display as Sunday. Or if num1 is equal to 2, you are to display as Monday. So this is an example of a switch case pseudocode, a switch case construct. To summarize, we have looked at variables and constants. We've looked at data types. We've looked at using operators. We've looked at conditional execution. With variables, we said that variables are the memory location, okay? The memory location of a variable. They represent the memory location of a variable. And a constant also represents the memory location of a variable. But with a constant, the value is fixed throughout the program execution. If data types, we looked at numeric data types. Then we looked at character data types, and we said that the numeric data types, they are numbers, they take only numbers. And with a character data type, they can take a number, an underscore, a value, or a character. And with operators, we've looked at our arithmetic operators, we've looked at logical operators, and we looked at relational operators. And lastly, we've looked at conditional execution, and we spent time with the if construct, the if else construct, the if else construct with a nested if construct, and lastly, we looked at a switch statement. So this is where we end with representing the program logic using pseudocode. Thank you.